Hello guys, Dr. Hasbullah here and welcome to our online course for fluid mechanics, right? I hope you guys are doing well at home. Please follow the rules of movement resolution order, manage your social distance, and you should be fine. Now we are at the second week of the movement resolution order, and at the first week, I'm pretty sure that we are quite happy to stay at home, right? If you stay in university, then you went to your hometown to see your parents. It's quite a nice feeling that you get a nice day off, right? And for me as well, suddenly I get to work from home. It would be nice. I get to spend more time with my family, with my kid, with my wife. But this is week number 2. And at the beginning of week number 2, I've started to feel that we've got a lot of work to do, and that we don't really know how to do it because we are stuck at home. Okay, the thing is, I have a story that I want to tell you, that how do we keep up this motivation, right? It's not that we don't want to do it, but our body, our mind is actually adjusting to the fact that we have to be at home and that we have to do things online, right? Imagine at work, okay, later you're going to come out, you're going to graduate, and you're going to work for a company, for example. So basically in Malaysia, the standard working hour is from 8 a.m. to 5 p.m. That gives you about 8 hours of work every day, and that total up to 40 hours a week, right? Imagine that if you work extra hard, okay, let's say you log in 80 hours a week, right? Say you are a bachelor, you don't have wife, you don't have kids, you've got spare times and you don't know what to do with it, so you work extra hard and you log in 80 hours a week, right? Now, let's see what happens, right? If your colleague that works 40 hours a week can achieve something in a year, you could actually achieve that in half a year, right? A year for you is like 2 years for them. So imagine where you will be 5 years down the road. You would have achieved things that he or she would achieve in 10 years, but you only did it in 5 years. All right? And back to our situation during this restriction order, imagine that if you continue to work 80 hours a week, right? And your colleague doesn't really know what to do or don't really want to do anything, and they work like 20 hours a week. All right, now you work 4 times longer than them. All right, see, now what you achieve in 3 months would take them a year to achieve. And if you keep this going for a year, right, whatever you accomplish in that year is going to take 4 years for them to achieve. Now, that sounds really interesting, right? It's very interesting because when this thing is over, when coronavirus has settled down and we start to go out, now all the opportunities will open, right? And everybody's going to go and grab that opportunities. But if you have done your work now, if you have worked hard now, if you have studied hard, try to understand things that you did not understand before, when everything settles, you're going to come out on top of anybody. You already equip yourself with the knowledge that others don't have because they are just too lazy to work. Okay? Now, when you go online, there are a lot of things to learn, of course, because you are taking fluid mechanics. You learn fluid mechanics, but don't limit your knowledge on just what you have to know, right? Explore the knowledge now online about what you can do, what you can know, right? Things like programming, for example, you can learn online. Things about marketing, internet marketing, you can also learn that online. So there's no harm in improving your knowledge, and take this time, take this opportunity to study very hard for your exams later, so that when everything settles down, you're going to be on top of things. Okay, now back to our subject. Okay, the way this thing works is that I'm going to keep each video short, about 15 to 20 minutes. I need you to go to this video twice. Okay, let me tell you how. All right, so firstly, you go through it once, right, and focus and try to understand what I'm trying to tell you. Okay, take notes and do whatever you need to do in order to understand that. Okay, and then when the first round finish, you go again and listen to the video for the second time. Only that for this second time, you take note of what you don't understand. I want you to take note what you don't understand and make sure to tell me when exactly you did not understand. Okay, for example, if I say something at 3 minutes and 15 seconds that you do not understand, so put in the comment section at 3 minutes and 15 seconds, what does this mean? Right? So that way, if the question is easy to answer, then I'm going to reply in the comment section. If the answer is quite substantial, then I may make another video to explain about it, because usually when you do not understand something, chances are there are other students who do not understand that as well. And I hope that is clear for you. So go through things twice. So first round, just go straight and try to focus and everything. And the second round, take note at where you do not understand. If you understand everything, that's perfect. But if you do not, then put in the timestamp and ask me the question. I will try my best to answer them. Alright, so we're going to continue with our topic, which is a boundary layer theory. And I'm going to write on my iPad and I'm going to show you the recordings. And you can treat this iPad as a whiteboard. I always write on the whiteboard. So treat this recording as you see me writing on the whiteboard. Okay? Right. We agree from before that a boundary layer will occur whenever there is a free stream of flow goes onto a flat surface. Right? So if this is your surface, okay, this is your flat surface, and there is a free stream flow coming on, and there is a free stream flow coming from the left at the magnitude of u infinity. All right, the free stream velocity u infinity could be 10 meter per second, 3 meter per second, so whatever it may be. And then you will have a boundary layer that looks something like this, and then it grows bigger like this. Okay, and the first part here is called laminar boundary layer. Right, and the second part is called turbulent boundary layer. Alright, and this boundary layer is going to keep growing as long as the surface is there. And if I mark here as x, right, and then this distance, I'm going to call it xc, which is called the critical length, right, the critical length. And this critical length is the length at which the boundary layer shifts from laminar to turbulent, right? So if I were to take a Reynolds number, okay, you know that Reynolds number is equal to characteristic length of something multiplied by its velocity divided by the kinematic viscosity, right? And the characteristic length for flat surface is the distance from the leading edge. Okay, and the leading edge is here. Let me mark. The leading edge is here. So it starts with x equal to 0. Meaning that as you go along this direction, you will have a different Reynolds number, right? And I'm going to call this Reynolds number Re x, which is equal to x times u divided by, okay, which is equal to x times u divided by nu, right? And when x equal to xc, that is, remember, xc is the critical length. So Reynolds number becomes critical Reynolds number, that is xc times u divided by nu. So the critical Reynolds number is where the boundary layer shifts from laminar to turbulent, right? And what is the Reynolds number for laminar? Okay, the Reynolds number for laminar is less than 3 times 10 to the power of 5. Okay, and the Reynolds number for turbulent region, okay, is Reynolds number greater than 5 times 10 to the power of 5. And in between this is called the transition region. And transition region is not fixed, right? It depends on the surface roughness and some other things. But we will not be covering transition region in this subject. So we'll only cover laminar and then we'll cover turbulent. All right. And okay, so this is called REX. Okay, REX means that the Reynolds number that's changing according to X. And X is the distance from the leading edge to wherever your X is. Now that we've established that there are two regions of boundary layer, which is laminar boundary layer and turbulent boundary layer. Let me mark it here. So this is laminar boundary layer and turbulent boundary layer. And we know that the transition occurs at x equal to xc, and the Reynolds number at which this transition occurs is for laminar is Reynolds number less than 3 times 10 to the power of 5 okay, and for turbulent is that Reynolds number greater than 5 times 10 to the power of 5. And let me repeat this to you again, that this number could change, but this is the general number that we usually accept for the transition between laminar to turbulent. Okay, now let's dive in a little bit more on what's happening inside a laminar boundary layer. Okay, if I take a line, let me mark it as red color. If I take a line here, okay, and I want to study that line, so I'm going to zoom it in at this region only. Okay, and if I go down here and I plot this line, right, so this is the zoom in of this line, right, and this is your plate. Okay, so let me mark it here. This is your plate. Okay, and remember that this is the line that I zoomed in, right? So let me mark it here. So this is that line, right? And let us study this line. Okay, now for this line, we know that when the flow touches the surface of the wall, what happens at, if I do y direction that goes up, so at y equal to 0, what do you think happens to the velocity? Velocity will be 0, right? That's because the molecule that is on the wall will stay at the same velocity as the wall. And as in our case, that the wall stays at 0 velocity, so the velocity will be 0, right? Right. Now, as the velocity goes up, as y goes up, right, and the velocity started to go up, okay, the further away it is from the wall, the higher the velocity, until you come to the edge of boundary layer. Okay, and this will form what we call a velocity profile. Okay, it looks something like this, and this is called the velocity profile. Okay, so here, this distance here is known as del, or we call it boundary layer thickness. I'm going to write it here. Del is equal to boundary layer thickness. Boundary layer thickness, right? So what is the velocity at y equal to del? Okay, what is the velocity here? And if we look at our figure here, the velocity at the edge of the boundary layer will be the velocity of the free stream flow. It will be this velocity. Okay, so at y equal to del, u here is going to be equal to u here is going to be equal to u infinity. Alright, I think in your book, u is equal to 0.99 u infinity, but it's quite the same, right? So u equal to u infinity. Right, so I'm going to put another condition here at y equal to del u equal to u infinity. Right? Okay, so what are the conditions? What are other conditions that we can derive from this figure alone? Okay, I can also say that at y equal to del, there is no more change in u, right? Because u will always be u infinity, right? So du over dy now becomes 0. Okay, because if I plot the velocity here, right? If I plot the velocity, let's use orange this time. If I plot the velocity here, right? It will always be u infinity, right? There's no more change outside the boundary layer. Okay, let me erase that again. Right, and one more condition that I can extract from this is that at y equal to 0, right, the second order derivative for u will also be 0. Okay, now with these conditions, right, I'm pretty sure you can imagine what I'm going to do next. Alright, now our next task is to actually find the equation for the velocity profile. What are the equations that represent this velocity profile? Okay, let's say, what if I do u equal to, okay, now if I were to plot this in the form of a graph, okay, so now if I do here y and this is u, okay, I can plot it like this, right? And to make things easier, I'm gonna, okay, you know that this is 0 and here is u infinity, right? And to make things easier, can I plot y against u over u infinity? So here becomes 1. Right? Does it make sense? Okay. Now, I want to find the equation that represent u over u infinity as a function of y. Okay, for example, I can do u over u infinity equal to a plus b y. Okay, so if I take a equal to 0, then if I want to plot this equation, right, this is y, this is u over u infinity, I'm going to get this line, isn't it? Okay, but this line is not what we are looking for, right? We are looking for something that looks like that. Okay, so to find something like that is actually, so this usually in the form of polynomials, right? So it could be second order polynomial or third order polynomial, right? So my equation is likely going to be it's likely going to be u over u infinity equal to a plus by plus cy squared. It could be like that, right? Or it could be u over u infinity equal to a plus by plus cy squared plus dy cubed. It could also be that, right? Now let's move things a little bit. So I'm going to move this a little bit here because this is going to the edge, right? So let's say I'm going to work on this equation. Okay, let's try and find a, b, and c. Okay, now how do we find it is we use this relationship. Alright, now let's see. First, we have at y equal to 0, then you do u equal to 0. Okay, so u will be 0 equal to a plus b times 0 plus c times 0 square. Now obviously a becomes 0. Okay, so that's your a. Now let's do at y equal to del, y equal to del u becomes u infinity, right? So at y equal to del u becomes u infinity, meaning u over u infinity becomes 1 equal to a is 0. So okay, so we know that a is 0. So I'm going to do b times del plus c del square. Right? Obviously, we have one equation, but we have two unknowns, so we cannot solve this yet. And let's see what we can do next. Okay, so now our relationship number 3 is that at y equal to del, then du over dy is going to be 0. Okay, now for this, you're going to have to differentiate the velocity function. Okay, so our velocity function is u over u infinity equal to a plus b y plus c y square. Now we know a is 0. Okay, a is 0. So u is equal to u infinity times by plus cy square. Alright, what happens when we differentiate this? So this is du over dy will equal to u infinity. This is b plus 2cy. Alright, and we know that at y equal to del, right, at y equal to del du over dy will be 0. So this is u infinity b plus 2c del, right? And what you have here is b equal to minus 2c del. Okay, when you have this and you also have this equation, right? So let's say that this is equation number 1 and this is your equation number 2. I believe now we can find what is b and what is c. Okay, let's do equation number 1. Okay, now b del plus c del square equal to 1. Let's write again, b del plus c del square equal to 1, and b is equal to 2c del. So this is minus 2c del square plus c del square equal to 1. So this is minus c del square equal to 1. C equal to minus 1 over del square. Okay, and that's how you find C. And B is equal to minus 2c del, and we know C is, so this in purple, so we know what C is, so just plug in there so that we can find B. So this is minus 2 minus 1 over del square times del. So your B will be 2 over del. Right, and that's how you find B and C. Now let's go back to our original equation here, right? And you end up with u over u infinity equal to A is 0, right? A is 0. B is B is 2 over del. And C is minus 1 over del square. Okay, so easily we can get u over u infinity equal to, okay, so that is 2 over del times y minus 1 over del square y square. Alright, sorry about this. So here, let me write it again. So you're gonna group this as 2y over del minus y over del square. Okay, and this equation is your final equation to represent this curve. Okay, to represent this curve. Okay, so this curve might be u over u infinity equal to y over del minus y over del square. This is 2y over del minus y over del square. Could be that. Okay, if we have A, B, and C. So I think it's enough for now because the video is getting quite long and I want you to go through it for the first time and then go through it for the second time to ask me questions. And if you don't understand anything, please drop me a comment, and it's available, it's online, it's public, so you can go through it as many times as you want. Okay, and I'll talk to you soon. Bye.